Welcome back. It's so great to have you here for another explainer. We're going to take a pretty complex topic today and break it down so it makes total sense. We're actually looking at one of the biggest ironies of modern tech. I mean, we live in a completely wireless world, right? We stream movies on the train, we text from coffee shops, and we just kind of believe it's all magic in the invisible airwaves. But here's the crazy secret. Our entirely wireless world, it relies completely on highly specialized, very physical cables. So today, we're decoding the hidden wires of wireless. Here's our roadmap for today's explainer. First, we'll uncover the secret to wireless. Second, we'll go inside an LMR cable. Third, we're sizing up the options. Fourth, a little showdown, LMR 300 versus LMR 400. And finally, we'll see how this is powering the world. Let's just dive right in.
All right, Section 1, the secret to wireless. We're talking about solving attenuation.
So how does wireless communication actually travel? Seriously, think about this for a second. Before your text message or your streaming video ever hits the invisible airwaves, it has to make a highly volatile physical journey from a transmitter to an antenna. Now, in the past, older standard radio frequency cables, the traditional RG series ones, they faced a massive hurdle called signal attenuation. Essentially, as the signal traveled down the wire, it just kind of lost energy and faded out. And look, if that physical bridge is weak, your data literally never even has a chance to reach the air. Enter our hero, the LMR, or low-loss microwave radio cable. This thing is the absolute unsung hero of our modern infrastructure. It's a high-performance 50-ohm coaxial cable specifically engineered for RF and microwave transmission. The magic is quite literally right there in the name, low loss. It's designed from the ground up to deliver significantly lower signal loss than those older, traditional cables. That means the high-speed, long-distance wireless communication we rely on every single day, this is what actually makes it possible. Moving on to Section 2, inside an LMR cable. Let's zoom in and look at the microscopic anatomy. Now, before we peel back the internal layers, you've got to understand this one fundamental number, 50 ohms. This is the absolutely critical impedance rating required for this type of high-performance transmission. Think of impedance kind of like matching the size of a hose to the water pressure. If the cable isn't perfectly calibrated to exactly 50 ohms, well, the data signal just bounces back, creates total chaos, and completely ruins the transmission. So everything, and I mean everything about an LMR cable is meticulously engineered to maintain this exact 50-ohm electrical environment. Okay, let's look at how this heavily armored tunnel is actually built, going layer by layer from the inside out. Right in the dead center, the center conductor physically carries your delicate RF signal. Surrounding that is a foamed polyethylene dielectric. That basically acts as a precision spacer to drastically kill that signal loss we talked about a minute ago. Next up, a bonded aluminum foil shield acts as this impenetrable barrier against electromagnetic interference, and that's backed up by a tinned copper braid, providing even more shielding and some really crucial mechanical strength. Finally, a rugged outer jacket wraps the whole shebang up to fight off the elements and protect the system. And because of those inner layers, specifically that really powerful 1-2 punch of the aluminum foil and the copper braid, LMR cables achieve an incredibly impressive spec, greater than 90 decibels of shielding isolation. To put that into perspective, this level of excellent electromagnetic shielding aggressively blocks out outside electronic noise, it stops interference in its tracks, and it ensures zero drop signals. Basically, your data stays completely pristine inside that armored tunnel, no matter what kind of crazy electronic chaos is happening outside. All right, Section 3, sizing up the options. Let's talk about the sheer variety of scales. You see, network engineers have to work across a massive variety of scales. On the extremely small end, you've got the tiny LMR 100. It's just 2.8 millimeters thick, basically like a piece of spaghetti. And that's perfect for small internal runs like GPS units and tiny Internet of Things devices. Moving up, we have the LMR 240 and the LMR 600 for longer distance, higher power antenna installs. And then there's the absolute behemoth, the LMR 1700. Coming in at a massive 43 millimeters thick, literally thicker than a heavy-duty garden hose, this giant handles massive, high-power telecom infrastructure. The difference in physical thickness directly correlates to the immense power applications each cable can handle. Scaling our infrastructure requires a really precise, rigorous balance of diameter, power capacity, and signal retention. I mean, an engineer can't just slap the thickest cable on everything. It'd be way too heavy, insanely expensive, and virtually impossible to bend. But on the flip side, they can't use the thinnest cable for a massive cell tower either, because the signal would completely vanish before it even reached the top. It's a constant, uncompromising balancing act between cost, physics, and practical reality.
Which brings us to Section 4, LMR 300 versus LMR 400. Let's do a real-world comparison.
I want you to put yourself in the shoes of a network engineer for a second. You've got a strict budget you absolutely cannot go over, you have a tight physical space to wire, and you have a required performance target that must be met. You essentially have to choose between flexibility and ultimate performance. When the stakes are that high, which cable actually fits your project?
Well, on one side, the LMR 300 sits at 7.6 millimeters thick because it's thinner, it's lighter, it's a lot more flexible, and it has a lower cost. It's an absolute workhorse, ideal for medium-distance RF links where you actually need to bend the cable around tight corners. But on the other side, you've got the LMR 400. This one bumps up to 10.3 millimeters. That extra bulk makes it significantly heavier, less flexible, and definitely higher in cost. But in return, you get remarkably lower signal loss than the 300. So an engineer will gladly sacrifice flexibility and pay a premium for the LMR 400 on long-distance runs, like routing directly up the side of a tall building. But if they need to weave complex paths through tight server racks over a medium distance, they'll absolutely choose the nimble, cost-effective LMR 300 every time.
Now for our final segment, Section 5, Powering the World. Let's look at the global infrastructure.
The sheer breadth of LMR's use is honestly staggering. It is quite literally the hidden backbone of our entire society. It's hardwired into the 4G and 5G base stations handling our global cell traffic and the Wi-Fi networks radiating through our homes. It drives massive industrial SCADA systems that monitor factory pipelines and huge cellular distributed antenna systems, or DAS, that provide cell service inside packed sports stadiums. From amateur ham radio operators to mission-critical public safety networks keeping first responders online during emergencies, it is everywhere.
And why is it chosen for all of those massive critical systems? Well, it all connects right back to those microscopic specs we explored earlier. It delivers very low RF attenuation, meaning the signal stays incredibly strong over long distances. It has that greater than 90 decibel excellent shielding keeping the noise out. Crucially, its rugged outer jacket provides UV and weather-resistant outdoor options, so it effortlessly survives baking in the sun on top of mountains and skyscrapers. It remains remarkably flexible compared to older, rigid hardline coax cables, and it boasts a wide operating frequency range, easily reaching up to several gigahertz. It's simply the ultimate, no-compromise choice for tough outdoor conditions and wide-frequency operations.
So I want to leave you with this final thought today. The next time you walk past a massive cell tower, or even the next time you look at the Wi-Fi router sitting on your desk allowing you to watch this explainer, ask yourself what hidden cables are keeping you connected to the world right now. Because while the invisible airwaves get all the glory, it is the physical, heavily armored, brilliantly engineered LMR cables that actually do the heavy lifting. Thanks for joining me on this explainer, and I'll see you on the next one.